My name is Professor Rad, and today we're going to introduce our third unit, which is all about fractions. Hooray! So I wanted to make this very brief video just to introduce kind of the concept of what we're going to be going for and sort of set the scene for our exploration of numbers throughout the next two chapters. So just kind of a review of where we've been in our exploration of numbers. At first, in our first unit, we thought about numbers just as amounts. So this could be like how far you drove, it could be how much money you have in a bank account, it could be how old you are, could be how many laps you swam in the pool, how much money you have, right? So amounts as in quantities. And then in our second unit, we discovered that sometimes not only do you want to know how much, but you also want to know where, like in which direction were you going. So we added directions to numbers. So we had not just how many miles you traveled, but did you travel east or west? Did you travel north or south? So we could use a plus to indicate one direction and a minus to indicate the opposite. We could have, okay, maybe you have $253.40 in your bank account, but maybe you owe somebody $53.16. So how do we indicate the difference between having and not having, or being owed versus owing somebody money? Or what if you change direction? So you walk up 5 steps and then you go down 18 steps. So what is that going to look like? So depending on what it is you're using numbers to do or to represent, you may want to indicate some kind of direction. So our third unit is going to add another feature to numbers. Now, not only do we want to know about an amount, but we also may want to know how big that amount is. So think about things that you're comparing. I like the second idea here, like you eat 3 slices of a pizza. And if I say I ate 3 slices of a 10-inch pizza, if that pizza is cut into 16 slices, that's different than if the 10-inch pizza was cut into 4 slices, right? So not only do I want to know how many slices of pizza I ate, but how big was each slice? Like how much was each pizza cut into? We might also want to know things that are related to each other. So I want to keep those values together in my comparisons or in my conversations about numbers. So for example, going 55 miles from one city to another in a certain amount of time. So we use information like that all the time when you talk about how fast you drove. Well, you drove 30 miles per hour. So 30 miles, 1 hour. That's how fast you were going. So we do this sort of comparison all the time, and that's what fractions allow us to do. They allow us to compare things that are related, whether that's how far and how long, or whether it's how wide versus how tall something is, or how many versus how big, right? So two numbers that are somehow linked, and we're going to be doing things with them while they're linked. So we've sort of really made a number that's made out of 2 numbers when we're creating fractions. And so something we're going to have to look out for, something to think about as we move forward, is how are we going to have to change how we operate on numbers because of this added heft to them. So for example, in our second unit, we learned that, if I'm walking in the same direction, if I go 10 miles east and then I go another 3 miles east, then that's an accumulating. They're working together, so I can add like normal. But if things are working in opposite directions, I have to now do the opposite of adding. I have to subtract. So when we add components to a number, now we're adding comparison features, we have to account for that when we talk about adding. So for example, if I ate 3 slices of a pizza that was cut into 16 slices and another slice of pizza that was only cut into 4 pieces, then how much pizza did I eat total? So you have to consider the fact that, well, the pizza sizes were different sizes. So how can we find a way to make like some sort of common unit of measurement there? We do that all the time when we make change. For example, if you had to make 35 cents, you could have a quarter and a dime. So 1/4 plus 1 dime is 35 cents. So a 25-cent piece plus a 10-cent piece will get you 35 cents total. So even though we're using those words quarter and dime, it's not like I say 1/4 plus 1 dime is 2 quarter dimes, right? So when you have some sort of size or comparison, you have to take that into consideration when you're adding and then subtracting and multiplying and dividing and so on. So what mathematicians do when they create new objects like this or when they begin an exploration is they have to remember that mistakes are going to happen. It's not that these objects are inherently hard, it's just we've got to be careful with them. And you have to be willing to try out new techniques. And when you make a mistake and you realize, oops, I can't do that, let's go back and think about the properties of my object and how that impacts what I'm doing with it, and try to move with the object based off of what the object is and what it means. So I've kind of babbled on a little bit long here. So really my goal here is just to say, look, we're going to be looking at new kinds of numbers, and we have to understand those numbers before we can operate them on them. So our chapter 5 is all about understanding the components of numbers that are now built out of this like comparison of amount and size, or how far and how long. And then in chapter 6, we're going to take that understanding of our objects and start to operate with them. Then we'll start to add and subtract and so on. So in the next video, we will talk about really what those parts are that make up a fraction. We'll start to discuss that. And we'll discuss that in terms of something called a ratio. So I'm looking forward to seeing you then. In the meantime, have a wonderful day.